Hey everyone, welcome back to the channel. Today we're gonna cover about what's semi-supervised learning. One of the most fascinating area in machine learning that sits right between supervised and unsupervised learning. So whether you are a beginner or someone look to strengthen your understanding by the end of the video, you will know exactly what a semi-supervised learning is and why it is useful and how it works, and we're gonna cover the code snippet of this video, right? So what exactly is semi-supervised learning? Well, it's a machine learning technique that use both labeled and unlabeled data to train a model. So you might wondering how can you find the difference between this both two, right? So label data is data where you know the correct answer. For an example, picture of cat and dog, where each image is labeled cat or dog. So unlabeled data is a row without any label. So imagine you have hundreds of cat and dog picture, but most of them aren't labeled. So in real life, label data is really expensive and really time consuming to get. So while unlabeled data is often, it's really abundant everywhere. So semi-supervised learning gonna help you make the most of both, right? So I'm gonna tell you why semi-supervised learning is really important. Suppose you have, let's say, 1,000 images, but only 100 are labeled. So if you only use the label data for supervised learning, your model gonna perform not that well because it has seen too few example, right? Now if you decide the 900 unlabeled images using semi-supervised technique, your model can learn pattern from all the data, making it much smarter and more accurate. So this approach is really essentially useful in area where labeling is really freaking expensive. Yo, slow, like I'm gonna tell medical image, right? Speech recognition or this classification. We're gonna use this more. So how it works, right? There are few common methods you can do, right? Gonna be self-training. So the model predict label for unlabeled data, then retrain using this predicted label, and there is a graph-based method. Uh, Imagine connecting data point in a graph, right? So label from label point propagate the nearby label point. And third is consistency, which is the model is trained to produce consistent prediction on unlabeled data, even if we slightly change or add noise to it. So essentially, the model is learning from both label guidance and the structure of unlabeled data. That's why we call this as freaking semi-supervised learning. And you might thinking, what are we gonna use this both? I'm gonna give the raw plethora of example I can tell. One gonna be medical imaging. So most image are unlabeled. Unlabeling image, require expert. Semi-supervised learning reduce the manual effort. Text classification. I can give an example. If you look at a spam mail, you might have some label email and tons of unlabeled one. And speech recognition. The huge data sets exist, but only a small portion is transcribed. So the model is gonna learn from both, right? So uh, you can think this is some sort of Peter Parker learning to be a Spider-Man. So he has some formal training from Uncle Ben. That's your label data. But most of his learning comes from observing and practicing on the street. That's your unlabeled data, which we don't know. We cannot predict the future. So if you combine both, Peter became a better hero, right? And just like that, and semi-supervised learning makes AI models smarter by combining label and unlabeled data. I'm gonna summarize before we getting into the code area. So semi-supervised learning is a hybrid approach between supervised and unsupervised learning. So you can leverage both label and unlabeled data to improve your model performance. It's especially useful when labeling is freaking expensive, but large amount of unlabeled data do exist right now, and that's a duty we need to obligate as an AI engineer, especially if you are an expert of that. So if you found this explanation really helpful, I'm gonna go to the next one, which is gonna be the most important one, which is code snippet. Hey, welcome to the channel. Now we're gonna cover what SSL more into the code area, which is really important if you're building, let's say, a medical imaging platform or anything, which you need to have that knowledge. So first we're gonna cover import and setup. First we need to import all this necessary library, which is torch and torch.nn for building your neural network, torch.optimum for optimizer, torch vision datasets for loading your MNIST datasets, and transform for normalizing and converting image, and numpy and random for reproducibility here, and then we're gonna set random seed to make our result reproducible. This is gonna ensure that if you run the code again, you're gonna get the same split of label and unlabeled data. We're gonna define hyperparameter like let's say batch size, learning rate, number of epoch, and ratio of labeled data. For an example, let's take if label data is equal to 0.1. It means only 10% of the data sets is labeled and the rest is unlabeled, right? Next is how we're gonna prepare the data. Next we're gonna define transformation to normalize the image. Normalization ensures that all pixel value are scaled between -1 and 1, which is gonna help the model train faster. We then load the MNIST dataset, which has 16,000 training image of digits from 0 to 9. The key part for semi-supervised learning is splitting label and unlabeled data. We're gonna calculate the number of label and unlabeled sample, and we're gonna shuffle the data sets into sets and select the first chunk as labeled and the rest as unlabeled. We then gonna create PyTorch data loads, for label and unlabeled test data, and here data loader allow us to load data in batches, very efficient during training. Now you're gonna wonder how we build the model. We define a simple CNN, which is convolutional neural network. It has two convolutional layer to extract, feature from the image. There's gonna be max pooling and dropout to prevent overfitting, and two fully connected layer that output the probability of 10 classes, digits from 0 to 9. This is a standard architecture for image classification. Ain't gonna work better with MNIST. And fourth gonna be the loss and optimizer. We use cross and drop loss, which is really common for classification tasks. We also choose Atom optimizer, which gonna adapt learning rate for each parameter during training. And fifth is semi-supervised training loop. Here what we're gonna think is really interesting. In SSL, we combine supervised loads from labeled data with unsupervised loads from unlabeled data. For labeled data, we're gonna calculate prediction and compare them with the actual label. This is standard supervised learning, right? For unlabeled data, we generate pseudo-label. These are the model prediction treated as label for unlabeled sample. We calculate loss on both label and pseudo-label data, then sum them to train the model. So by iterating over label and unlabeled batches, the model gonna learn from both known and unknown data, improving performance without recurring 100% label data. Then we take evaluation. So after you've done the training, we test the model on the menace test set to set its accuracy. We're gonna put the model in evaluation mode, run prediction on test data, and calculate how many were correct. Finally, we print the accuracy percentage. This is gonna show how well our semi-supervised approach worked, right? I'm gonna give you a few important things to remember here. So semi-supervised learning works best when labeled data is scarce and unlabeled data is plentiful. This is my advice for you, because if you work, let's say, in medical imaging, let's say AI healthcare diagnostic platform, you're gonna encounter with a lot of let's say unlabeled data, which you need to, you know, go for the data pipeline and pre-process and do a lot of things, right? And at that point, it's gonna be hard to get whatever result you want. So you can improve the pipeline using consistency, regularization, mismatch, or fixed match technique in advanced settings, right? This is a great way, and that's it. I hope this gonna be really helpful, right? We're gonna line by line we did through a full semi-supervised learning pipeline in PyTorch, including the data preparation, splitting, model pipeline, training, evaluation. If you like this walkthrough, make sure you hit the button and, subscribe. And if you have any doubt, I'm sure you need a comment below. I'm gonna answer that. If you want a full tutorial with advanced semi-supervised methods, you can ask me in person. I'm gonna cover that. And that's it. Thanks for watching, and I will see you in the next video.